This problem is number 2 on the Newton's second law practice problem worksheet. This problem deals with a rock hanging from two ropes, A and B. In this case, the ropes are not symmetrical. One hangs at an angle while one pulls horizontally. So we have a rock, and the force diagram was actually given to you in this case. W pulls down. There is a rope going this way, which is labeled A, and there's a rope going this way, which is labeled B. And we are told that this angle here is 60 degrees. We're given the following information: that tension in A is 50 newtons. As I said, theta is 60 degrees. And we're asked to find tension in B and the weight of the rock. This is a static equilibrium problem. We're assuming the rock is permanently at rest. And in order to understand this problem better, I'm going to draw some vectors on our force diagram. I'm actually going to redraw this force diagram a little larger. So A goes this way, weight goes down, B goes over, and A is the only rope that is pulling in 2 dimensions. A pulls over, so I could call that TA in the X direction, and A pulls up, we could call that TA in the Y direction. Since the rock is in equilibrium, the net force in the X direction has to be 0, and the net force in the Y direction has to be 0. So those two statements are what the conditions are for static equilibrium, and they lead us to the following conclusion: that TAX must equal B, or tension in B. In other words, as much as A pulls to the left, B has to pull to the right. So these forces here are equal. Likewise, we know that TAY must equal W, or the upward pull of A has to equal the downward pull of weight. I can actually calculate TAX and TAY because I know that the tension overall in A is 50 newtons, and I know the angle is 60 degrees. So TAX is 50 newtons cosine 60, and that will be our value for TB. And TAY is 50 newtons sine 60, and that will be our value for W. Cosine 60 is a trig angle. I expect you might know cosine 60 has a value of 0.5. So 50 newtons times cosine 60 comes out to be 25 newtons. So that's one of our answers, the tension in B. And calculate W, it's 50 newtons times sine 60, or 43.3 newtons. And that brings us to the end of problem number 2.